Hi, everyone. Thank you for tuning in to our Python Learning Labs. Today we have Patrick Smith, who will be going through how to unlock zero CVEs by migrating your Python application to Chainguard Images. I'm Kirby Koo. I'm on the community growth team here at Chainguard. And before we get started, I just wanted to do a little housekeeping. So if you take your gaze to your right, you should see a little chat box and a little question box. You can chat in the chat and tell us where you're tuning in from. And then if you have any questions, you can comment it under Q&A. Any outstanding questions will also be filtered there so that you can always go back and see the answered questions or outstanding questions. With that, I'm going to hand it over to Patrick. The stage is yours.
Hey all, welcome. I'm real excited to be talking to you today about how to unlock zero CVEs by switching to your Python application, such as a Flask application, a Django application, to Chainguard Images. Just a little bit about myself. My name is Patrick Smith. I am the Staff Developer Relations Engineer at Chainguard. I'm from Queens, New York. I still live here. I grew up here by way of Ireland. If I start talking a little too fast or something like that, that might be the Queen's influence a little bit. In previous lives, I taught the boot camps for researchers at Python, on Python and R at Columbia University. That was a lot of fun, and also got to work with some organizations like Space Telescope Science Institute, who are the scientific center for Hubble and James Webb on their Python infrastructure. So when I'm outside of work, you'll catch me playing around with my little daughter Lily, or swimming in an ice frozen lake or an ice bath. And I do have a PhD in digital humanities, so you can look that up. I didn't make it up; it's a real thing. And I'm really, I love teaching Python. I love teaching Docker. I love teaching Chainguard Images, and I actually am really excited to show you how you can migrate your Python application. So let's look at the agenda for what we're going to be doing today. Agenda, what are we going to be doing? I'm going to be giving you an overview of CVEs, the modern CVE ecosystem. We're going to talk about what that is. There could be a couple of stupid pictures and jokes. And then we're going to talk about Chainguard Images and how they can help you hit that magic number, zero. Is that a real thing? Zero? Zero sounds like a big jump from maybe a couple dozen, couple hundred, which is pretty standard. We're going to talk about that. Then we are going to write a very short Python application, something like 10 lines. We're just going to write it out. I'm going to use Flask, which is a great, very minimal, batteries not included in a good way, framework for creating web applications in Python. And we are going to containerize it using some, kind of by design, some random container, Docker file that I found on the internet, which is not really best practices or whatever, just to show you. But that is probably what you will start with when you Google around to containerize your Python application. So that's the example. We're going to change a couple little things into 2 lines, just two, not even 2 lines, 2 half lines. And then we're going to compare before and after the CVEs using an automated scanner. And then once we're done with that, I won't spoil anything on those scans or whatever. Once we're done with that, we're going to do something a little more technically advanced, and that is going to be doing a multi-stage build for your Python application. And I'll get into what that is and why you would do that. It's pretty cool. It kind of even puts you way past any kind of peers in terms of how secure your application is going to be after you do that, because it removes a lot of stuff that you really shouldn't have in your production applications. If we have time, which we probably won't, given my testing or whatever, but I will gesture toward this. I'll gesture toward creating a more sophisticated setup for your Python production application because Chainguard also offers images for things like Nginx and standard databases. So I'll kind of gesture toward that at the end. We probably won't have tons of time for that. Okay, so what do you need for this? Prerequisites. You need Bash. I will also say there's something here that you should have that I didn't put on, but a text editor. You need to have a text editor like VS Code. If people ask me what text editor should I use, I usually just say VS Code. In this tutorial, I will be using Emacs because I'm a weird Emacs person. But if you're wondering, use VS Code. You should have a text editor. You should have access to Bash. So don't be using Windows PowerShell or whatever. Or you could use Windows Subsystem for Linux probably. And you'll need access to Git, so you can download the example code if you want to use that. That's more for your reference. And then you will need Docker Engine to run. We'll really only be using two Docker commands here, which is the Docker build and Docker run. So if you could do that, you could follow along here, or you could just copy what I'm doing. But you will have to have Docker Engine installed to follow along. And then, of course, the most important thing, you will need a burning hatred of CVEs, okay? So you will want a desire to make your application more secure, okay? If you like security problems and you like, things not working in your application, then maybe this isn't the workshop for you. But if you don't like those things, then maybe this is the workshop for you. All right. So what are CVEs? And we have kind of a ridiculous meme here a little bit. So we have this is the famous meme, the creepy little girl at burning house meme. And the creepy little girl is the CVEs, your application, and you can also think about it, your production environment or whatever is the burning house, okay? And what CVEs are, what are they? They are common vulnerabilities and exposures. They are known vulnerabilities in software that can affect your application. And there's a whole modern ecosystem around CVEs with databases that register CVEs and various tools that can scan software artifacts of various kinds, including images, which is mainly what we'll be talking about today, but also other kinds of software artifacts for CVEs, okay? And they will usually categorize them by critical, high, medium, and low. And so I will also just say, before we move on from this meme, don't feel bad that, if you're laughing or whatever, this is a funny meme, because apparently this little girl, she sold this meme a couple of years ago for like $450,000 for one of those NFTs. Okay, so it did pretty well. And in fact, this meme is actually even more popular now after that happened. So, all right. So, what are Chainguard images? Well, first of all, you might already understand this, but it's very painful to try to remediate CVEs. Okay, if your task was remediating CVEs, you have to take your application, run it with a scanner, find the CVEs. They're listed by like letters and numbers. Look them up, then check your application to make sure they're relevant to the application. Then you have to manually make changes, either by pulling the absolute latest in software, trying to get that to work on your on your application, or by manually configuring things. It's very painful. So what Chainguard images are, they are images created based on our Wolfie OS, which is a minimal distribution, and we call it Distroless, but we'll talk about that word Distroless later. Distribution, Linux distribution, and these images, they come for various stacks that you would use, so Go, Python, Node, or JS ecosystem, and also for various tools that you would use to develop applications, such as Nginx, databases. We have special variants for certain kinds of compliance, like if you're government or have other government requirements, FedRAMP. We have FIPS images, specialized FIPS images, and they are low to no CVEs. So what does that mean? Let's skip really forward. So low to no CVEs means that if you scan one of our images, chances are the most likely outcome is that you're going to see 0 CVEs in there at any given time. You may see 1 or 2 depending. And here we have a comparison. This is specifically for Python. It's the last month's worth of recognized CVEs. On the left, you have the official Docker image for Python. On the right, you have, which is, yes, you're seeing nothing. It's an empty graph. You're seeing the CVEs detected in our own images, okay? And I believe I have this page open. So you can actually Google, if you Google around for this is on our Chainguard Academy website, which is a great resource for learning about these things. you can see this vulnerabilities comparison for Python. You can see all these vulnerabilities listed. You can scroll. Tons of vulnerabilities listed for a lot. Vulnerabilities listed for Python. Yeah. I never actually scrolled to the bottom of the page. It's really long. And then if you click the other tab, which is ours, it's empty. And that's because typically in this image, we actually get it down to 0, which is pretty remarkable. And look, how remarkable? Well, I mean, when I started using Chainguard Images, I found it very surprising that you could get down to 0 CVEs. And is it the case that is it magic powers? Do we have, I don't know, like what people ask, well, how do you get to 0 CVEs? Specifically people ask, is it the power of love that gets you to 0 CVEs? Okay. And I wish people would stop asking this question because it's kind of a weird question. Guys, stop asking. It's not the power of love that gets us to 0 CVEs. I will tell you what the secret sauce is, however. It is incredible toil, incredible, painful, difficult work by a team of amazing people at Chainguard. And specifically, while our folks at Chainguard are toiling to make get these images down to 0 CVs, what are they doing? It's a couple of different things. You can see them listed here, but things like, first of all, our images are extremely fresh. So when new code is released that remediates CVEs, it's usually pulled into Wolfie OS within something like 4 hours. Other things would include things like, I mean, you probably know this a little bit if you've tried to remediate CVEs yourself. Configuration, so that could be manually going in and changing files so that the CVE doesn't affect the the image. Or it could be things like doing advisories, working with scanners to make sure that scanners are up to date with whether or not a specific CVE is relevant to the software. Because if you are remediating CVEs, probably a lot of the times you realize, oh, actually, this doesn't affect our use case for the image. But it's still something you have to look into, and it still takes an incredible amount of work. It can take almost just as much work to figure out whether or not a CVE is relevant than to remediate it. So these are all really important. So it's keeping things up to date, and often we will actually we will ourselves develop a patch if it's not being fixed upstream or something like that. So we will also do that. So it's freshness. We develop our own remediations. It's the advisories, working with other groups. These are all the ways that we it's just incredible work though, and by an incredible team. And also we have people who are amazing at this, and we've hired them, and you can't have them back now. So okay, so that's basically Chainguard Images. We are right now going to jump straight into demo. So I'm going to switch over to the command line, and to follow along, you can go to this code here. So go.chainguard.dev /Python-migration. Okay, go.chainguard.dev /Python-migration. So we'll pull that up now. And actually, I already had it open in another tab. And this is a GitHub repository that has code in different branches that you could follow along. And we have basically 3 stages here, which is sort of a naive containerized application. That's number 1. Kind of like if you just followed a random, Docker tutorial for containerizing a Flask application, which is, it's fine, but, they will have a lot of vulnerabilities and stuff after that. That's step 1. Then we will make a couple little changes. That's step and check to see what the CVE level is. That's kind of step 2. Then we will do a multi-stage build, and then, which I'm going to talk about more again later. I will explain what that is. Don't worry. And then finally, we may not have time to get to this, but the code is in here, a little bit of an orchestration. So it uses Docker Compose to orchestrate between the Flask application and Nginx, the Nginx image. Okay, so for a nice kind of production ready environment. Okay. And if you want to pull this, I mean, obviously you can get clone up here the normal way, but because this is stored in branches, I've put some code here. If you copy this and paste this in the README, it's a little halfway down the README here. You copy this and paste it into the command line. This should fetch all the branches, okay? And each of these stages, the V0 branch is the first one, and so on. There's different branches for the different stages of what we're going to do, if you want to follow along. Also, you can click these links, and it will bring you to the branches here in the browser. So, if you don't want to, if you're not the fastest with, git check out this, git check out that, then you can also just follow along, clicking on these and going to the different branches, and you'll see different files and so on, different states of the project here in the web interface. Okay. If people have questions now before the demo, this is probably a good time to pause before we go, straight into the command line and start hacking. So is there anything coming up, Kirby? Are we good?
All good. Sorry, it took me a minute to join the stage again.
No, perfect. And thank you. I was like, wow, am I still talking to people? Am I just sitting in a room by myself? But sometimes you get that feeling. Okay, so let's go ahead, and you're going to want to open your command line. And what we are going to do is first, I'm going to go into a projects directory. So you don't have to do this, but basically what we're going to do is create a new folder for this project. Okay, so mkdir. We'll call this Flask _ app. So, and I'm going to cd into Flask app. Okay. And people wondering, I'm using Z shell. So if it looks a little different from yours, you might just have a $sign and your name of your computer or whatever. That's fine. They're pretty much the same. Bash and Z shell are pretty similar, so everything should work. Okay, mine just looks a little bit different. Okay, so we're now in our in a nice new folder. It doesn't really matter what you call it, but you should have a nice new folder. Nothing in it, nothing cluttering things up. And now we are going to start we're going to create a file for our Python application. Okay. Hopefully. Okay, so what I did there is, and I will just do it again really quick, just so people aren't confused. If you're using VS Code, you would do something like type code, and then the name of the file, app.py, or do whatever you would do to start a blank text file using your preferred text editor. Okay, I'm using Emacs. You could do vi app.py, whatever. It doesn't matter. Nano app.py. Nano is available on practically everything. You could do that. Okay, so I'm using Emacs, so I'm typing e app.py. So when you see e, that's just me using my text editor. Okay. All right, so we got a nice fresh file. We feel a whole world of possibility opening up before us. Now let's go ahead and we're going to import Flask. And remember, Flask is our framework. So from our web, it's a framework for creating web applications in Python. From Flask, import the Flask object. So capital F Flask. Okay. And then we're going to do app equals Flask object name. And no, I'm not going to type everything out in this entire tutorial, but we're going to use this little app a lot. So I'm just and it's short, so I'm just going to go through it. App equals Flask _ name. And people always get confused about that _ name thing. It basically is the name. It's either main if the app is imported it was run directly, or it's the name of the file. In this case, it's app.py, so it'd be app if the file is imported. Okay. So, and you could just put a string there. It doesn't really usually matter that much in most cases. Let's do def index. And actually, I need to add a root. So it's at app.root. I love that Flask syntax with these decorators. This at syntax is really lovely. Basically, just syntactic sugar for like a closure. But if you wanted to think about it another way, it's a kind of a way of modifying functions. Really cool. Whoever came up with that is a genius. Let's just do, for now, let's just do return. I'm going to come back and make this a little fancier, but let's just make sure it's working. Okay. Return test. So I'm just saying it's defining a function that only returns the string test. And then we write, this is basically the last thing we do, if __name _ equals quote __main underscore quote app.run. Okay, and what does that do? Basically, it means if we run the app directly, then this part of the code gets run, this app.run gets executed. If we import the code, it doesn't get run, okay? Which is useful in some circumstances, okay? Then basically we are finished with this. We're gonna come back and clean and do something a little fancier so we have a nicer example, but let's just make sure it runs. One other thing we're gonna need to now add is our requirements.txt file, REQUI. My spelling is not my strong suit. REQUIREMENTS.txt. Doesn't actually really matter what it's called, but that's the standard. Flask. And I'm gonna just write Flask in here. And remember, requirements.txt, it's a text file that each line is one dependency for your application, and you can pip install, and then it will install everything. Okay. I do recommend if you're making a production application, you do want to pin these, okay? But I'm not going to pin it for now, but you want to do Flask equals and a version number, okay? And for various security-related reasons, basically, it makes certain kinds of attacks more difficult. So it's a good idea to do that, okay? We got our requirements.txt. We got our app. I'm going to create a virtual environment. I'm going to use that environment to run the application. Then I'm going to delete it because once we containerize the application, we won't need it. I'm just making it to show you that the app works. Okay. So I'm going to do Python mvenv for virtual environment command. And then I'm going to call it venv. So it's Python -m venv, or virtual environment. It'll take a second to run. And then we need to activate the virtual environment, okay? Remember, these are little environments that manage our dependencies in Python, okay? So we're going to do venv bin activate. Okay. So now we can install, and we'll install just to this virtual environment in this folder. So when we install packages using pip, it will go straight into that folder, and it will be accessible from the bin file, but they're not actually binaries, but the little symlinks or whatever that are in there, okay? So let's do pip install r requirements.txt, okay? And it should install into this folder. And then when we access Python, we should have access to Flask, which is the dependency that we set. So let's do Python app.py to run our app. And of course, there is some kind of error problem. If name equals, I did equals and not equals. So that's very big problem there. So app.py. Okay, cool. Okay, so that should fix our issue. There we go. Okay, so remember, equals assigns variables. Python 101. Okay, so our application is running. It's running on port 5000. So I'm going to open a browser. And of course, because I'm sharing my screen, the alt tabbing is all messed up. Okay, so open a browser, and I'm going to do localhost :5123:5000, and we have test. It's working. Let's just add one little thing to this just to make it prettier, because we're going to be using it more. So app.py, and then I'm going to just add some little octopuses, because that's fun. Okay. So octopuses. So the octopus is our logo for Wolfie, the minimum, and also for Chainguard. So Wolfie is our minimal OS. I'm adding a little octopus emoji. And I'm going to add 30 of them, multiply by 30. Octopuses equals octopus emoji multiplied by 30. You don't have to do this if you don't want to do it. Return h1 my app. That's a heading level 1. And then I'm going to make a paragraph with our octopuses. Okay. And then, okay. So we have a nice little application. We're going to have to add an F to this so that the string formatting works. You don't have to do this. You could just leave it as test if you want, if you're not feeling it enthusiastic, or you can write whatever you want. I'll run it again. I'll tab properly, localhost. Okay, and now we have my app, and we have nice 30 octopuses. So it's a very proportional number of octopuses, okay? So now we just want, that was all just checking that that application worked. So now we have a nice regular Flask application that runs locally. We're going to use this. We're going to containerize it. I'm going to remove the virtual environment that we set up just to see if it works, because we are going to have virtual environments that run inside the container. Okay, we don't need one outside the container. So I'm doing rm-rf. Then if you're not comfortable with those commands, you just move it out of another folder or do something else. Some people get scared of these commands, but it's fine. So we deleted our virtual environment folder, and now we're going to containerize the application. So I'm going to do Docker file. I'm creating a new empty text file. Okay, and this is the part where I'm not going to type the whole thing out. Okay, so I'm going to insert a Docker file. Okay, so I will walk through it with you, however, of course. So this sets some of this you're going to see in every Docker file. This sets the command and the syntax for the commands. Here we use we have from Python that uses as our base image the default Python Docker container. Okay. We set the working directory, so that's the directory that all these commands will run in. We copy the requirements.txt to the container. We run pip3. We install the requirements using pip. And notice that I just grabbed this from the internet. This is like the first thing that came up on Google. There's stuff here I would not do personally. It's they're not using a virtual environment, which is fine in some circumstances, but and then this copy dot, it just copies everything from the folder. I probably wouldn't do that either. I would copy things explicitly. But whatever, this is what comes up if you're Googling. It's sort of the naive example of an application. Okay. And then this last line, it will run our entry port is probably bash. This runs Python 3 and starts a Flask application. So I'm going to save this. I'm going to go back to the command line. And this example is in that repo that I shared with you at the beginning. So if you want to copy this out, copy it from there. It's in the v0 branch of the repo that I shared at the beginning of this. Okay, or if you're referring to this later. Cool. So now we have a Docker file, we have requirements.txt, and we have our app.py. And of course, what we do now, we build it. So we're going to do Docker build dot. So dot meaning this folder. We're using the Docker file in this folder, and we'll give it a tag. We'll give it a tag, I don't know, basic Flask. Okay. Installing. You can see it installing with pip there. And then we're done. So we should have an image built now. That's called basic Flask. I think that's what I called it. So let's do Docker run it. We're just going to see if it works. So we're running we're going to run a container from this image we built interactively with IT. And then I'm going to open a specific port or expose a certain port onto the host machine. So it's going to be 5.123, 5,000, 5.123, 5,000. So inside the container, it's running on 5,000. Outside the container, it's going to run on 5,000. And then I called it basic Flask, I think, hopefully. Okay, it seems to be running. So I'm going to look at my host machine and see. Yep, there it is. Okay, so it's the same application. Now it's running in a container. Okay. When you close this and when we check again, yeah, it's not running. Okay, so we've containerized a Flask application. Cool. So this is kind of the normal way you would do it. I guess the quote unquote normal, you would use the default image on Docker. I used some random code I found on Google that came up to the top that would be recommended to people to do. Okay, now I'm going to do compare. So I'm going to do gripe. I'm going to do gripe basic Flask. And what is gripe? It's a scanner for CVEs. And we're going to see how many CVEs are in this kind of naive Flask application that I've created. Okay. And remember, this application has no dependencies, no anything. So it's not, pretty much the CVEs are not going to be related to the application. They'll be related to the base image mainly. Oh my God, it printed out so much that it's hard to even scroll up. So actually, what I'm going to do is I'm going to redirect the output to the CVEs that get spit out to a text file. Okay, so we can actually see what we're doing. That's what happens when you have too many CVEs. You have to scroll. So, okay, so it's running and nearly done. Okay. So what do we got? 5 critical, 67 high, 149 medium. So let's not even worry about those because we have something to worry about. That's a lot of critical CVEs, you know. I mean, if we look at them, we could do cat CVEs, graph, critical. Just to look at the critical ones. I mean, that's five critical ones. Like critical, see, they're called critical because they're bad. So you don't want them. Okay, so that's a lot, and they're this is because we use the base image. The base image that's the default image on Docker. Okay, so what we're going to do now is just change 2 little things in our application, and then we're gonna use so that we use the Python Chainguard image as the base image, and we're gonna then scan. Okay, so we're gonna open up not the Docker files, but we want to open up, and we're just gonna change 2 little things. The first one is obviously the most important. We're gonna, instead of using the default image, we're gonna do cgr.dev Chainguard Python latest dev. Okay, so that's cgr.dev. That's our repository. Chainguard Python is the name of the image, and then the tag is going to be : its latest -dev. So this is our developer image, and we'll talk about the distinction why we have developer images, why we have other kinds of images. Okay. Now let's do. We also have to do one more thing, which is we have to change the. There's a reason we have to. The entry point is going to have changed. We use different entry points for our Python images and for a lot of our Chainguard images, and I'll explain why that is later. But for now, we just want to remove this Python 3 from the beginning, okay? Because we already have the entry point set to Python, so we don't even need or want that. Okay. So saving the file. Docker build .tag cg. I'm going to call it cg flask. So cg for Chainguard. Okay, it's installing our deps, our flask, dependency or whatever. Okay, looks like it's done. Docker run. Let's make sure it works. It -p 5 1 2 3 5 1 2 3, and we called it cg flask. Okay, it's running. We're gonna check localhost again. Yep, works. So it's the same application. We just used a different base image. It's the exact same application. We just used a different base image. And now let's test. So it's going to be gripe, and we're going to, what did I call it? I called it cg flask. Okay, let's run. And I'm not even going to bother to redirect the output because it's going to be a lot less output. I'll tell you that much. Okay, so we run it. It has 5 outputs down here. I'll explain what those are. But let's take a look at the severity. So the CVEs that we have here, severity, 0 critical, 0 high, 0 medium, 0 low. Okay? So that is a massive, it's 100% reduction down to 0 CVEs. And it's only because we switched the base image. We did nothing but switch to Chainguard images. And now we have 0 CVEs in this application. So awesome. Now, what are the ones here? These are ones that are quote unquote unknown. So they're under analysis. Okay, so these aren't actually CVEs yet. They're ones that will probably become CVEs soon, or they will be rejected or whatever. They're under analysis. Okay, so they're not at the point where we can remediate them yet. So that is, okay. So we did a thing. We switched to Chainguard images. We changed 2 things, and then we have 0 CVEs. So that's cool. Very quickly, I want to talk a little bit about Distroless, and then I'm going to check the time, but I think we should have time to still do the multi-stage build. I will check that. So I'm going to switch back to my presentation here. Demo time. We're still in demo. We're always in demo time here. But what is Wolfie? So Wolfie OS is a Distroless OS. It's a Linux distribution. We call it Distroless, and that means it's a philosophical term. It means a certain approach to creating distributions. And basically it means there's very few dependencies. And this is the really thing to have to wrap your head around. There's no shells, so no interactive shell inside the container. And yes, that can make it harder to debug and stuff. And there's no package managers in there, okay? Now, however, we provide the developer version, which has those things, the shell, the package manager. And then we provide what we call our latest image. So, and that is our production image. And that is an image that is, there's no shells, no package managers, okay? And I'm going to show you how you can kind of use those in concert. But when you think about it, like you use shells and use package managers for development, but in production, they're liabilities, because what do shells let you do? They let you run code. What do package managers let you do? They let you download arbitrary code. So in production, you do not want those things, and in fact, you really don't want them. What's the solution? How do we develop the software using the tools that we need, but also in production, we get rid of these things that are liabilities? There's different approaches for different software stacks, but for Python, what we're suggesting you do is a multi-stage build. So essentially, in your build process, in your Docker file, you're going to use two different images. And then you're going to copy the software artifacts from the setup you've created on the developer image over to the production image in the final step. Okay, and we will try to very quickly do that together right now. And okay, yeah, we haven't gotten to this yet, but this is a little advice on how to debug the images. Okay, so we're back in our Flask app folder, and I just want to, I'm going to open the Docker file, and we're going to make this a little more sophisticated. And if you're following along, this will be in what is called the Python-only branch in the repo. So you have to switch to the branch that says Python-only. You'll git check out to Python only, and it'll be the code that we're going to use now. Okay, so I'm going to erase this Docker file we had before, and I'm going to stick a new one in, and I think, okay, yeah. So I'm going to give you a little tour through this. It's 3:38. I want to have a little time for FAQ and everything for you guys. So, but we're not really in a rush. We're on a good time here. So Docker file. So from the beginning here, we're using a Chainguard image, and it is our developer image. And you can see that tag here at the end. Okay. Okay. Latest dev is dev. We've labeled it. And then, so we're using our development image. And then what we're doing, we set the working directory, and we provide, we create a virtual environment. So it's creating a virtual environment within the container. Then we change the path. So we actually set the executables within the bin folder in the virtual environment as the first part of the path. Okay, so it kind of preempts everything else on the path. So that basically means that's basically saying on the path, you want to supersede whatever default binaries, Python binaries, whatever. We're going to only use the ones in the virtual environment. We copy our, requirements.txt file into the environment, and then we run pip install. So basically, once you do these, you're all set up to, you have your virtual environment. That folder contains our dependencies and, the Python pip, all the bin files, quote unquote, that will run our application. So that is what this part does. Then we actually switch over to our Python latest. So this is our production image, okay? Then we copy the software artifacts over. We set the working directory. We copy the app over. We copy the virtual environment from the previous image, and then we set the path again. And then that's basically it. Remember that. And this sets some metadata, and in this case, instead of using 5,000, I've set it to 8,000. And also, I've used the G unicorn, so green unicorn server here, WSGI interface, which is a little more production ready. So we will actually need to quickly add that to our dependencies as well. Okay, so I'm adding that to our dependencies. So now the dependencies are Flask and G unicorn or green unicorn. And remember, you want to pin these probably if you're making a production application. So this is our multi-stage build. We use 2 images to create the final image. And the difference here is that in our final production image that we build with our application, there will be no package manager, there'll be no pip, whatever. And also there will be no bash, okay, no shell. And in some of our images, we use ash as well, okay? But the important part is there's no shell. Let's go ahead and build this. Back to the command line. Docker build dot t, and we will call this multi-stage or something like that. Multi-stage. Okay. Not the best name, but naming things is hard, as you know, in computing. I think that was sort of cached. I might have used that name before, so it built really fast there. Okay. But we should have our image built there. Docker run it p, and we're using 8,000 this time instead of 5,000. 1, 2, 3. 8, 1, 2, 3. Multi-stage. Okay. And it's running on the application. Let's go check. Local host. We're not doing 5,000, we're doing 8,000. And there's our familiar application with our 30. And now, just to try this out, I mean, we could do the scanner again, but even with the developer image, we already had 0. So we'll quickly do the scanner. But there's another thing I want to show you that's actually more relevant to the multi-stage build. So it's gripe multi-stage. That's the image we just built. Looking. Yes, 0 CVEs. Now but at this point you're bored. You're like, oh, 0 CVEs. I've seen it before. I'm using Chainguard Images. Of course, it's 0 CVEs. I would be disappointed if it was anything else. But here's another cool thing. Okay, Docker run it. Let's change the entry point to bash. Entry point bash. And then we're going to do our application multi-stage. Okay, so this is, and we get an error. Why? Because now there's no bash in this image that we created. Okay, there is no shell. And yeah, that does make it a lot more secure, because how are people to execute arbitrary code in your environment? I mean, there are obviously ways, but it makes things more secure. Just to compare, if you do it with a regular Python image or whatever, yeah, there you go. You get a, and not only that, it's root. And that's another distinction between our images. Our images, by default, they default to the non-root user. Okay, so they do not have root permissions when you run an image. So that's another way that the Distroless images are more secure. They run as a non-root user by default. And in this case, it's running the root user. You see that little, who am I? Root. Yeah. And do you want to run in root in production? Probably not, right? I mean, we have for many years, for 50 something years, we've had these distinctions between privileged and non-privileged users, and we're kind of throwing it out here. So basically, there's a lot of reasons these are more. The main thing is, if you switch to it, even if you use our dev images, you're getting 0 CVEs. But with the multi-stage build and embracing the whole Distroless philosophy or whatever, you actually entering either an even more sophisticated level of security. And I don't know, it's hard to go back then once you hit that. So we're pretty much at the end here, but there is a challenge with Distroless, and that is it's harder to debug these images. Why? Because you can't just run a shell in there and kind of poke around ls, check the environment variables, blah blah blah, which is tricky. I mean, I do that when I'm debugging images, and there's tooling that will help out. Lately, I've been using a tool called CDebug, which will it will basically sideload a bunch of binaries and other stuff into the image, and then allow you to have that environment. There are other tools. The one of them, which is pretty cool, is Kubernetes has these ephemeral containers that are useful for this purpose. And also Docker has come out with something called Docker Debug. However, you do need to be, I think, a Docker Pro subscriber to use this Docker Debug. But it is very good and cool and everything like that. So, if you're a Docker captain, or if you have access to Docker Pro, then I would definitely recommend checking that one out. Okay. Okay. So, and I think we have one more thing. So I've got them kind of ending the demo, but I just, this is the last meme here. Basically, it's our Wolfie, which is our it's our mascot for our tiny OS, our tiny images, and for Chainguard. And he is the smallest octopus in the world. And in this video, the Wolfie octopus, which is smaller than your fingernail, only like a third the size of your fingernail, a tiny octopus. You barely see him. He's digging a little hole into the dirt, which I personally think is cute. But that's our philosophy: is to make the images small, to make the images secure, and still usable. And that's basically the end of this tutorial. And hopefully we'll have a couple of questions in the chat lined up.
Yeah, we have quite a few. Thanks, Patrick.
Excellent. Thank you.
So I'm just going to read them out to you as we go.
Yeah, fire away.
Steve is asking, since there's no bash or command line on the production containers, does that mean we cannot perform any run commands in the second stage of the Docker file?
You can't perform commands. You can perform run commands, but the entry point is, and thank you for asking this question, because I maybe didn't hit this point hard enough, is that the entry point is set to Python. So there is, obviously, it's a Python image. We have Python on there. But the entry point is set by default to Python. So if you want to run a CMD command, whatever, then you do need to double check that if you're using CMD, then anything gets automatically sent to the Python executable or whatever. But what you probably want to do is at the end of your Docker file, you want to use the entry point command. You can totally use normal Docker run commands because they don't depend on, if you want to do copy, the other kinds of Docker commands, but yes, you want to be doing most of the run commands on the development image. So you want to try to set up all your software artifacts, whatever you need, and then copy them over. Okay. Now, are there things that will make difficult? Yes. There's different kinds of setups that will make it difficult. In those cases, there's kind of different things you can do. You can either, work with us to make a custom image. That's a possibility. Become a customer. We'll help you make a custom image. Or you can go back to Wolfie OS, which is free and open source, and try to build something on Wolfie OS with the packages that we have there and build your image from scratch. That's another possibility. Or you can run our dev container. And if you run our dev container, you can benefit from 0 CVEs. But what you're not getting is that like Distroless, don't have a shell, don't have or whatever. But you're still kind of miles ahead because you have 0 CVEs. So you do get that benefit, but you don't have the Distroless bit, which is no package manager, no shells. Hopefully that answers the question a little bit, and that was a great question.
Okay, sounds good. Next question from Containers from Scratch. For something like a Go application where it will almost always be statically linked, is there any reason not to just build it with the Scratch image? What advantages would the Chainguard /static image have for that use case? I see there's a comment.
I would say CVE remediation, but what I would recommend is our first learning lab with Kirby and Adrian was all about static images, and specifically with Go example. So I definitely, and I was just looking at it earlier today, and I would say take a quick look at that. That's maybe someone could link that in the chat, and that would be where I would go take a look for a pretty in-depth look at that.
Lisa just did that, so thank you so much.
Awesome. Thank you, Lisa. Lisa's always on
it. Ooh, the formatting of my screen just got a little crazy. Okay, so Lucas asks.
Maybe it's because of this repeated. Let's go back to the start so you don't have to look at.
Hold on a second. Okay, here. What happens when we install a Python library that provides some .so libraries? For example, PyCurl provides a lot of shared libraries. Should we trust on them, or we should use Wolfie packages? How do we
basically it depends on the library. I would say if pip can handle it on its own, it's fairly likely to work with this multi-stage build thing that I showed you. But if there's definitely some packages that need to be like OS level, in which case the multi-stage build is just not going to do it for you. And in that case, the options are those three things that I shared with you. Either use the dev container, which allows you to use APK add, the Alpine package manager, package keeper, whatever it's called, to add packages from Wolfie OS. That's a possibility. If the package isn't in Wolfie OS, there's the option to package it yourself with Melange. You can work with us. We'll make you a custom image. That's a possibility. Or yeah, you could just use the dev container but then you don't get the advantage of that distroless approach. But yes, I mean, these are real questions with the approach, so it'd be more suited for certain kinds of dependencies than others. I would also say we have a lot of other packages to build on, so sometimes there will be packages specifically for, I forget what example you used there, but I'm trying to think of other examples. But there will be packages that will have other sets of useful, dependencies to build on.
Hi, Curl.
Definitely take a look through our package catalog and see if there's anything else that suits as well.
Okay. Great. Thanks, Lucas. Next question from Alvaro. Even if there is no bash shell, the Python REPL is still there, and that could be used for similar purposes as bash. Is there a way to disable the Python REPL?
I mean, ultimately, it's if you include the Python executable, the Python. I'm trying to avoid using the word binary because they're not really binaries. But if you try to take those out, then you can't run Python code. So, ultimately, I mean, I agree, being a purist, I mean, the most secure application is one that has no running software, you know what I mean? And it's also why, sometimes it makes sense to just build a static website or whatever and just serve things statically. And that's the most secure thing because we don't have running code. Now, if you're running a web app, then it obviously you're a level up in terms of functionality. You're running code in production, and that means that there are ways that people can interact with that code. So yeah, it's a thing to keep in mind. It's something to know, but yeah, I don't think as far as I know, there's no way to take that out. The REPL is kind of indistinguishable from, there's not really a distinction between, I'm running this text file and running, the interpreter and then typing stuff in. That's just kind of a detail. What you ultimately have is that, that environment that allows you to run Python code. So if you want to run Python code, you kind of have to keep it. So, I mean, maybe I'll bring it up with our labs team actually, just in case I'm missing something there, and just to double check. But as far as I know, there's no way around that. And if I'm wrong, please, someone else who's smarter than me share in the chat. But that's my take on it.
Oh, cool. Sounds
Thank
good.
you, Alvaro.
Final question that we have here from Alexa. If we use the non-dev in the base image we're using, can we still use APK add-in, say a services?
No. Yeah, I mean, I should have been more explicit about that, but that's, the whole philosophy of the, that latest tag, the production images, is not to allow arbitrary code to be downloaded into the environment. So that's one of the package managers. We not only don't have pip, but we also don't have APK. So if you have to use those, then, again, just those three free or whatever options, but build from scratch, work with us to build an image, or use the dev. Those are basically your three options.
Okay, I think those were all the questions.
Great questions. Thank you.
And we're almost at the top of the hour, but one final thing that I wanted to announce is that our next Learning Labs is June 25th. It'll likely also be with Patrick. So I'll just drop the link in the chat and make sure that you all sign up for the next one so you don't miss it.
And we're going to be doing some image classification. We're going to be detecting animals. So it's going to be AI. We're going to be doing our new PyTorch, CUDA-powered PyTorch image that is in beta right now and should be launched next month. So really excited to be there for that one. It's going to be fun. I'll also just quickly say, I'm psmith01. My Smith has a Y in it. It's a common name. There are a lot of Patrick Smiths out there, but it's PSMYTH01 on Twitter. So feel free to @ me. And I'm on LinkedIn, just put in Chainguard, whatever, Patrick Smith. And you can also send me an email at patrick.smith, smyth, @chainguard.dev. And I'm, pretty responsive. So go ahead and just drop me a line if you have questions.
Great. Well, thanks, Patrick, and thank you everyone for joining, and we'll see you in June. And
Thanks,
feel
Brittany.
free to send us at Patrick or myself any suggestions of upcoming learning labs if there's any ones you want to hear about. Thank you. Have a good day. Bye.